Thank you very much. Welcome back, everyone. Just a quick recap for those excuse me, those of you that came this morning. I have done a little bit more on the thing I was scraping all the paint from this morning. I'll just give you a quick look. We'll not dwell on it, but let me move you to overhead view. With me a second. There we go. So there it is. Look, it's got all the inside motion installed now. It all works very nicely, and I'll bob on with that later over the weekend. Put that back safely in its box. Right. Well, I thought we'd just do some straight building today. Why not? So I build commercially, and I've just finished building a model of a 280 LNER 01 loco, and that's sat just behind my laptop there, waiting to be torn to pieces and sent to paint on Monday. Now, I don't know whether anybody follows the forum, but I have a thread usually on my workbench, and this was a little project that I did just before Christmas. It's I'm just unwrapping it. I like wrapping things up in cling film, you see, because if anything falls off, like a screw or a pin that's holding the valve gear, then it kind of lands in the there in the cling film, and I can retrieve it later. Anyway, as you can see, it's a chassis and a footplate. Can you see that? Can you see that? It's a chassis and a footplate of this, which is a Stania 8F Gladiator kit, and this was the project I did before Christmas. I built the chassis with all the valve gear. This all works. It's fitted with a DCC decoder just there, but no, it's just a straight DCC. There's no DCC sound or anything like that. It's just a very simple bread and butter build, and it's going to be my next job. What we're going to do, and we should more or less start today, right now, is to build the body. As you can see, the thing exists so far as a chassis with a footplate on the top. So I think probably the first step is to take the footplate off, and what we're going to do is we might even read through the instructions, shock horror, and build the cab. So if you can just bear with me for a few seconds while I take the screws out that hold the chassis to the footplate. I can release the footplate and we can offer all the cab parts up to it and see where we are. Right, there we go. So we'll pull the DCC decoder or the stay alive unit. So that's the footplate. That's the chassis. We can put the chassis out the way for now. We'll wrap it up in its cling film just in case. Also, it'll save the thing getting covered in all the filings I'm about to make. So here it is. This is the kit. The inside should be the rest of the parts. So if we whiz open the box, what have we got here? We've got a receipt for some bits from U-Choose. We've got bags of castings that will come to in due course, no doubt. We've got some bearings which we're not going to use. More parts, more screws, a load of handrail knobs. Crikey, there's some pretty heavy-duty instructions with this kit, aren't there? Wow. Anyway, I don't know whether you can see that, but that's a picture of the loco that we're ultimately going to build. It's an 8F that was based. Now, the client lives in Wakefield, which is quite near Leeds, for those of you that aren't familiar with Wakefield, and the guy models railways in and around Wakefield. And this is a picture of an 8F, and I think it was pretty sure it was allocated to one of the Barnsley sheds. Anyway, that's what we're building. Receipt from Slaters. We've got a bit of rolled up boiler. I've just I just finished an 01 loco, which was built from a Dave Andrews kit. And in his infinite wisdom, Dave had pre-rolled the whole boiler, and he'd not punched the rivets out around the smoke box. So really, the whole panel was scrap, because it's impossible to unroll material that's this thick, punch out the rivets and then roll it back up without distorting the thing to hell. So that went into the bin, and I made another boiler. I'm hoping that I don't end up going there with this one, because I was just looking and there's a kind of a row of rivets here along the top of the boiler. This is the tapered section of the boiler by the looks of it. I suppose the smoke box ultimately goes there and the firebox here, and I think, yeah, they've got bell pair fireboxes, haven't they? So we'll have to build a bell pair firebox, but not today. I think today we'll start by let's have a look at the cab. There's some chunky white metal castings there. We've got a smoke box door casting with loads of gabby blowholes there from the casting process. So I don't know what we're going to do with that, I suppose. Customer won't want it with loads of holes in it, so I suppose we'll have to either repair it or get another one 3D printed. Got a receipt for a motor and gearbox that's now in the thing, and here's all the etchings that we have left. So box over there on the spot. So I'll find the cab side etchings and the cab front. Now there's a cab front, so I suppose a good place to start would be cutting that out. So here we are with some big tin snips nipped to the edge of the me saw, and I'll cut through the tabs there so we don't distort anything. I think when I'm building a kit, I usually start with the chassis. In fact, I always build the rods first, because it helps you accurately locate the axle boxes in the chassis. So usually I start by making the rods. They're usually laminations in a kit like this, and over the years I've got quite nifty at yeah, they're usually like that. Look, this is the 8Fs had two different length con rods, and this is the etch that's left over for the, I can't remember whether the longer or the shorter con rods. I just can't remember. I think the con rods were made shorter on a 8F for some maintenance reason, and it allowed them to get parts of the cylinders apart without stripping the whole thing right down. We've got some panels there. I think that probably is the ones that, given that it's got a lot of holes in it, it's probably the one that becomes the firebox. And I think if you, oh god, it's got the dreaded multi-etched lines there on the other side to help you fold it up. But really all they do is help you put loads of creases and witness marks on the outside. So I think what I'll do with that is stick it on a sheet of 0.3 nickel silver and cut a new one out, drill all the holes in the right place and so on, make a new panel, and not try to bend that. I think people who etch boilers in, is 0.45 18 thou? People that etch boilers in 18 thou should try rolling up a piece of 18 thou to make a boiler. very difficult. And there's the cab sides. So it looks like all we've got is the cab sides. Oh, there's some laminates for the cab sides. Jolly good. Right, let's get this out of the way and get the cab sides cut off the frame. So, as usual, the process goes, cut the parts off the frame, well, it does for me anyway, cut the parts off the frame, and then clean off the etching cusps, which, you know, if you're a professional builder, most of my life is spent filing etching cusps off locomotive parts. And I'm sure there'll be a lot of that today during this demo. So the chassis, yeah, normally what I would do is make the rods. So I did make the rods first. And then I made the basic chassis. And actually the chassis was quite good in this kit. I mean, being an 8F, being a freight engine, it's quite a simple chassis in reality anyway. And I think did Dave Andrews design this kit? Probably didn't, because it says PG design there. Can't remember. Is it Peter Dobson PG design? But I mean, it's quite a good kit. All the panels for the chassis were pretty good. Didn't have to scratch build anything, as I remember. And the footplate folded up quite nicely as well. Look. Normally with Dave Andrews kits, often what you get is a whole panel that's got the valances attached to a fold-up jig, and you kind of try to fold it all up square and then build the platform on the top and then form this bit and this bit at the front. And I've always been useless at doing that. It's never really worked very well for me building these things in a jig. So I just cut them out, cut them off the jig, and but for some reason this kit it wasn't on a jig. You just got the balances, and actually that made it a lot easier because I soldered the balances to the platform, the main top part of the platform first, and then got this bit. And as I remember, I don't normally do this annealing parts, but I did anneal that, just holding it over the biggest flame on our gas cooker, and till it was cherry red, letting it cool. And it helped me a lot forming this curve here. And obviously you could use the valances as a guide to where you want to go. And the end of you've got it right when the end of the valance lands in the right place at the end of the etch. Because I suppose it's critical, isn't it? Because you've got to form this bit pretty carefully, because if you don't, then this part of the platform, the lower part, won't coincide with it won't be parallel and square to the top part, and then your cab's going to end up leaning. So I think it's really worth putting a lot of effort into making sure you get that bit and the bit at the front as well right. And it's a little bit trickier on these AFs. I mean, this front panel here, I didn't bother annealing that because really you're only curving the sides, the two sides of the panel, and the bit in the middle just stays flat. So I didn't bother annealing that. I was able to form that round some. I always bend them, by the way, around drill shanks. I've got a box here of metric drills that go from, I think, 1 millimeter up to 10 millimeters in 0.5 millimeter sizes. So, you know, these are perfect. The shank of the drill's perfect for forming panels, you know, using them as a former. But you can see with this drill, what I've done is I've actually attacked it with a grinder to get all of the. Sometimes when you use these drills in a chuck, they spin sometimes in the chuck, and you end up with a bit of a burr being formed where the chuck's grabbing the drill. And obviously, what I've done is by the looks of it, it's got grinder marks on it, so I've hit it with my slitting disc to get all the imperfections off the surface before I start using it to curve things around, because if you don't do that, you can end up with marks in your panel from spurs that are on the shank of the drill. Anyway, that's another story. But yeah, that's kind of how I made that. It was just done really by eye, but you really have to be quite accurate because that's the foundation for the whole body of the loco, really. And later, when I come to solder the boiler onto the when the boiler's complete, so what I'll do is I'll build the cab here and sort of build the boiler as a separate assembly, the boiler and the tapered parts, sorry, the firebox, the tapered part of the boiler, and then the smoke box. And I think there's a cast saddle that fits on here, and I'm willing to bet you all 200 quid each that the casting doesn't fit. So I'll end up scratch building something for that. For some reason, these sort of cast smoke box saddles never fit. The boiler ends up usually being too high. Anyway, we'll cross that bridge when we get to it. Oh, hang on, there's some. I'm gonna have to Welsh on my bet, look, because there's some etchings here that look like they could well be for a saddle. Anyway, all will be revealed in due course, I'm sure. So anyway, back to cutting these parts out. The chassis was very straightforward, and I always use. I know proper engineers need to kind of shut their ears now, but I always use jury axles for locating the axle boxes in the chassis. Simply because then you can use the rods as a jig, you know, and the only secret to making a O-gauge chassis run beautifully is to make sure that the rods and the axle box centers on the chassis are exactly the same. And I think manufacturers are always a little bit ambitious. They always pre-etch holes in which you are expected to let a top hat bearing into as the means by which the wheel turns. And I think the biggest, in my experience, the centers of those pre-etched holes in a chassis never match the rods, ever. And they only have to be out very slightly. And then, of course, your chassis starts to jam, usually at 12, 3, 6 or 9 o'clock. And if they do jam in those vertical and horizontal positions, then, you know, it's a 99% possibility that your rods and your chassis axle centers don't match. And I've read so many books where people then decide the way to cure that is to just run the thing to death overnight if needed, you know, to try and somehow attract the chassis fairies to come into your workshop and move your axle boxes around so that the rod centers now match the rods. But what you're actually doing is knackering the whole thing. And I know that's a really common problem, and I know that well, that's the solution to it, really, to not rely on the pre-etched holes in the chassis. Right. So what we've got here, by the looks of it, is a load of panels. Very good, very good. So I suppose what we'll do is whiz off all of these tabs that are used to locate the panels, the different panels on the frame of etchers, and we'll solder some stuff together. Well, it looks like we're going to have to punch out a million rivets first, but we can do that. Of course we can do that. Right. Remove this last... My saw, by the way, is just a cheap piercing saw that I bought. Well, I didn't buy it, actually. I acquired it from a girlfriend in a former life that wanted to become a jeweler, and she bought a load of tools from a lapidary. Is that the right word? Supply in Stockport near Manchester. And I acquired all these tools about, I don't know, 40 years ago, and they're all still going strong. So actually, they probably weren't cheap tools. The blades I use, by the way, in my piercing saw are 6/0 blades, piercing saw blades that I buy. I get these from Hobby Holidays, and I'm pretty sure he gets them from Squires. And they are quite expensive, these 6/0 piercing saw blades, and you will break a lot of them because they're very, very flimsy. But it's like all these things, isn't it? You're better off buying the most expensive tools that you possibly can because ultimately you save money. And I think that's been the case with buying expensive piercing saw blades because they tend not to be as fragile and they've got a little bit more flex for the occasions when you aren't hanging onto your workpiece properly and you end up snapping a blade. Anyway, as you know, all these etch kits end up with, they're all held into the frames with tabs that go all the way around the parts. And excuse me, to get rid of all the tabs, I always buy this thing here, which is a kind of a rotary sander arbor, and I think these come from Minicraft. I've got a couple over there as well. It's still in their boxes for emergency. And the pads here I make myself out of, I think it's 180. It is 180 grit, wet and dry. And what I do is I stick double-sided tape on the back of the sheets of wet and dry and draw circles with a compass and cut them out with a really knackered pair of scissors. Here, look. And they're great for just doing that and getting off the little pits there that and as you'll see in a second, they're really good for also getting off the etching cuff. That's what my life's become, filing etching cuffs. There we go. All very quick. There we go. That's the outer cab sides done. They're all prepped. In a minute, I'm going to have to file the etching cusps because the window beading is full etch, but the sides are only half etched. So therefore, because the way the etching process works, there's a kind of a, as I'm sure you know, there's an etching cusp on the edge of the panels always. Let's see if I can. There we go. No, there we go. At the top of the way the etching process works, the ends always end up with a pointed bit like that on them that we just need to file off. And the best way I found of doing that, again, is to use this rotary sander. Like that. Take the tip off first and then just whiz across with your rotary sander and the etching cust's gone. In a second, round the corner. And there's another one there. Top. Another pick there that needs to go. I'm just going to go get the etching cusp off that. All gone. Bit there. Finally then, now you have to be careful when you're doing this part because there's a tiny half etched bit at the bottom which is probably for the cab floor. It's where the cab floor will land. You don't want to put your rotary sander over that because it'll just chew through it in seconds. Right, that one's done. Right. And then a little bit of, I can't remember what this is, what grit this is, but just small wet and dry, just to get the burrs off around the edge. There's bound to be some burrs that I've created with the using a rotary sander in that way. So we'll just get rid of all those. We'll do the backs of these outer panels as well. And I suppose we should just, for the sake of completeness, do the cab front as well. There we go. That's all the etching cuffs gone, except they haven't, because we need to go inside the windows on this. Where's a bit of wood? Convenient bit of wood. And we'll just stand the panel on the bit of wood, and we'll start filing around the insides of the cab windows, the front windows. Get the etching cuffs off those, and we'll try and find a little tiny rat tail file here, and with a really pointy end just for taking out the corners, getting the etching cuffs out of the corners of the window. That one, that one's square. With the flat file. There we go. That's good. I see. I like this panel look, because it's let's see if I can make it see that. You can see the top of the panel here has got a whole series of holes. All these LMS locos always have loads of vent holes there along the top, and the designer's taken the trouble to etch them through. And I suppose what we're going to have to do is run a drill through each one of them to get rid of the etching cusps within the hole as well. So in a minute I'll find out which drill it is, and we'll quickly whiz through with a drill just to get the etching cusps out the hole. Yeah, right, drill. Start with a millimetre, shall I? Are they millimetre holes? They are not. Are they 0.9 millimetre holes? Just pushing I'm just offering the shank of the drill up to the yes, no. Are they 0.8 then? Yeah, they are. They're 0.8. So we'll put the 0.8 drill. Drill. With the knackered chuck. I do need to get a new mini drill. But I know I won't until this one dies. I know it's a bit anally retentive, really, drilling out all those holes. But if you could see this, you could see how much crisper they do look. Now they've been drilled out. That's kind of worth the effort. Right, let's just get the burrs off the edge, around the windows, and then we'll ding out all the rivets that are on the cab front, and then all the panels then have been prepped and they're all ready to go. It looks like that goes on there. The windows we'll use for alignment, and in fact what we'll actually do is put some rod through these little holes here that are pre-etched in the cab sides. There's some tiny holes. Can you see? They're where the cinder guards will go ultimately. And they'll be a useful kind of location point for sticking these two panels together. It looks like there's a half etched. When you laminate these two panels together, it leaves a rebate there that the cab front sits into. Yeah, that's exactly what happens. So the cab sides are two pieces laminated together, and obviously the outer panel's half etched to give you all the rivet detail like that. You know, I've got terrible trouble with my lighting. See all the rivet details there. And also, because it's an half etched panel, it's slightly bent as well. So and try and just tease it approximately back into shape. But of course, when I plant it on the no etched panel, full etch, of course they don't seem to curl up quite as badly. But it's a bit of a flaw sometimes in these etch kits, and everything is a bit curly. Just drop a straight edge on that. Oh, that's so good. Right. Rivet. Create a space for me. Rivet punching tool. While waiting to go. Here we go. This is my riveter. It's if Dave Smith was here, he'd like that, because this is one of his that I bought donkeys years ago, and it's kind of screwed to some MDF, so that I can lay long panels across these two bits of wood here are at the same height as the anvil there, so that long panels don't flop all over the place. But I'm sure you've all used one. They're very straightforward. You pull the handle and you create a rivet. See if I can just adjust the lamp so I can see punching the right hole. I did modify this anvil very slightly. I ground the edge of it away so that at no point is the adjacent rivet sat on the anvil, because if it is, then when you stamp a rivet out, you end up slightly bending the panel, and if you're not careful, you can end up with a very curly panel if it's quite thin. So I think not going mad is the key here. Just light presses, and you can see that the rivets are embossed quite nicely on the other side, just with a really light press.
While you're on the subject of doing this, Nick,
Yeah.
what do you do if the half-etched dimple is considerably bigger than the point?
Oh, well,
Because that happens a lot.
It does. I kind of guess it. I don't know. It's a good question, that. I suppose you could grind yourself a new pointer, couldn't you? And
Or a much bigger, fatter one.
yeah, make a much bigger, faster one. Well, I mean, I assume that the holes are made bigger so that you've got a deeper rivet. Is that the case, do you think?
Who knows? I doubt it.
No. Sometimes, as well, the slightly annoying thing about these parts is that sometimes the rivets aren't actually rivets in real life, are they? They're screw heads. And depending on the budget for the job, sometimes I will actually drill out all of the half-etched sort of pips and let fake nuts and bolts into them, because they just look better, don't they, at the end of the day?
They do. What I've found with
depends how much budget you've got, though, really.
Yeah, if I'm doing a wagon kit, what I tend to do is to pull the because you've got quite a sharp point on that particular rivet press, because I've got one as well. So I pull it until it touches the sort of hard edge of the dimple.
Yeah.
And then at least all your rivets are in line because they're all pulled to the same edge.
Yeah, I know what you mean.
And you get a a line properly spaced,
Yeah,
but it's not in the middle because you
yeah.
cannot, with the best will in the world, you're never going to get in the middle.
No, I mean this particular punch, I'm sure yours is the same. It comes with a kind of an end stop, doesn't it?
Yeah,
Because I was explaining right at the top of this presentation that one of the jobs I did recently was building an O1 loco from a Dave Andrews kit, and David rolled the boiler up and not
yeah,
punched out the rivets on the smoke box. So the whole thing was basically scrap. There's just no way you're going to unroll a 18 thou panel,
no,
punch the
no,
rivets
certainly isn't.
out, then roll it back up without it ending up just being a mess.
Mm,
So I just cut a new one. And in fact, I just had to measure it up because I couldn't even unroll the panel, could I? And so I did actually use the formers out of the kit, to be fair,
mm,
to the designer. But, I remember sitting here while I was putting it out thinking, sometimes I think the people that design these parts have never actually, built anything with them, because I don't know whether it's just me or other people have that problem, but I find it really difficult to roll boilers out of 18 thou material. I think 0.3 is 10 thou, isn't it? And if you roll a boiler out at 10 thou, it easily goes through your rollers, your slip rollers. And I just have I've got the Dave Smith ones, the Midland Railway blah. Got a set of rollers that he'd stopped making years ago. I actually found a set on eBay second hand, and bought those, and they've done me proud for decades now. But they don't, really thick material won't go through them. See, hang on a minute, I'm just having to think, because I need to punch these rivets in an order where the rivets aren't sat on the anvil when I punch the next one. There we go. It's just the way I've got the anvil orientated in the rivet machine. I could easily spin it round if I wanted to. But and this is even better television, this, isn't it? Watching me punch rivets out with a rivet punch. Great stuff. Scraping paint, punching rivets. There we go.
Nick,
Yeah.
you said you'd ground the top of your anvil. Can you draw us a picture of the shape that you finished up with?
Yes. Yes, I will. Just a second. Yeah, just got the last rivet there. Okay. Get rid of that riveting tool. Finish with that now. Right. Sharpie. You notice I got a new Sharpie the evening with I did the other week. Sharpie died. And I went to the post office up the street and bought a new Sharpie just for you. So the anvils are kind of that shape, cross-section wise, and they've got a thing there that your pointer goes into.
Yeah.
So if you're going across with a sheet of etched brass and it's got kind of half-etched dimples there, it's easy to punch that one. But when you go to punch that one will be here. So when you push that down, this piece of panel distorts slightly. And then when you do that one will be, are you with me? When you do that one's sat on the anvil. So this, then when you're finished, you end up with a panel that ends up like that with loads of, rivets on the other side. So what I did, I ground just on one side, because this, when you look down on the top, it's circular like that, and I ground a corner off it there.
Right.
So that was never, that rivet would never be sat on the top. The next rivet was never going to be sat on the anvil when you punch the adjacent one out. And also,
Right.
I did it like that as well, so that can you see that? Yeah.
Yeah.
I cut that piece. I ground that piece off as well, so you end up with the hole right in a corner like that. And then that way, when you're punching that way, and there's a previous row there, they are never stood on the anvil as well. Are you with me? So if you were to,
Yeah.
so if that's your panel and you've already got a load of rivets there that are pre-formed, and you're trying to do some here just below them, then these aren't sat on the anvil, so the sheet's going that way, so these never fall on the anvil together, but also they never fall on the anvil, and it just works really nicely. And Dave in the riveting tool, it has a kind of a cam shaped bit of plastic that fits on the top of the anvil like that, and you can twist it. If you're riveting on a panel that doesn't have half etched marks for punching out the rivets, you can use the cam shaped thing that Dave provides to get your rivet spacing, because your rivet spacing will become that. But if you rotate this, then the rivet spacing will increase. Are you with me?
Yeah.
And that's really useful as well. I think that Lee Marsh marketed something that was originally been developed by Tony Reynolds, didn't he? Where the riveting tool had an XY table on it, so you could wind the piece along and punch the next rivet, and then wind it along again and punch the next rivet. But I thought that was, I mean, I nearly bought one, you know, in that kind of rivet counters way, but I'm sure I'd have driven myself mad trying to work out what the rivet spacing should be. Although sometimes I've riveted a wrappers to go around, you know, a sort of a saddle tank engine. Think of a Peckett or something like that, some bog standard industrial, you know, sort of saddle tank loco, usually an 040 that were made in the tens of thousands and worked in gasworks everywhere. The wrapper for the saddle usually has rows of rivets, doesn't it? You know, kind of all the way along it, where the thing's been riveted up, because it's not just one big sheet, is it? It's strips that have, and often rectangles that have all been riveted together. And whoever does the riveting, the rivets always coincide, don't they? And that's quite tricky to achieve as well. And I have tried my hardest, you know, and with I think reasonable success with me non-XY table riveting machine, you know. So you do a line of rivets, and then you have to start the next rivet exactly in line with that one. Can you see that?
Yeah.
Exactly in line with that one. So start the next row here, and then hope that they all coincide, you know, using your cam tool here or whatever. And I'm sure an XY table would be much more useful for something like that. But it'd cost the customer an awful lot of money, wouldn't it, for me to do one panel like that with moving everything on an XY table. Sorry, that was a very long-winded answer to a short question, really, wasn't
That was
it?
that's really useful. I shall have to try that.
Yeah, I mean, it's it just stops the panels distorting. That's all it
Yeah,
was.
I have endless problems with that, where the panel distorts.
Yeah, I think you just need to. I mean, the riveting machine, mine's got a kind of an end stop as well here, look. Excuse me. Just here, where you pull the handle down. I can see if I can get it on in shot. There it is. Look. So the sort of handle comes over, and it presses that down, which creates the rivet. But this is an end stop. So I think what you need to do is adjust the end stop so that the anvil doesn't hit, the point doesn't hit the bottom of the hole in the anvil at your maximum deflection, because, you know, you need to kind of leave a thickness, don't you, that's sort of equivalent to the thickness of the material that you're trying to punch. So if your panel like this one is 18 thou, which is 0.45 mil, and it's half etched, then in theory you need to make the gap between the bottom of the point and the bottom of the dimple there. You need to make it 0.225 or something, don't you? You know, that's the thickness of the. I mean, I know that's only a rule of thumb guide, because etching's not an exact science, is it? You know, and sometimes they overcook the panels, you know, so the unetched bit's not half the thickness of the original material, you know. But yeah, try adjusting the end stop there, because if at the bottom of the the forming thing process, you end up squashing the material between the point and the bottom of that, then the material in the panel's got nowhere to go other than squidging outwards.
Yeah.
So it'll end up distorting it. It's inevitable, really, isn't it? Oh, excuse me. The dreaded lurgy. Has anybody else got any questions? Or shall I move on to soldering? I've got soldering a couple of panels together, if you like. Now, as I said, I was going to use the cinder guard holes as a guide, but I'll need to find the drill that's the right size. You know what? I think have I lost the drill? Well, I guess I have. My 0.6 drill's gone missing. I bet you 20 quid it's the 0.6 drill that I need. Oh no, it's not 0.7. Then I've got a broken 0.7 millimeter drill. The shank's broke off that one. So I'll shove that through there. Just have a quick think. There's the half-etched part. So that'll be mated with this one. Not right, no, this one. And I'll put the drill through both holes to align them. And then just check the bottom edge there. Got a bit of a block there. Make sure that's true. In the olden days, hobby horse developments used to do really nice cast cinder guard frames that would have looked really nice on this. But alas, Simon is no more. Well, that's not a bit untrue. Simon's a great builder. He's still around, but hobby horse developments have passed away into the ether. Right. So
Hi, Nick. I'm watching.
Oh, hello, Sat. I knew you were.
Hello, mate.
I knew you were. I saw you at the beginning. Yeah, they were great little castings, weren't they? Were they in your Tony Reynolds range, I think, weren't they?
They were the original hobby horse.
Oh, they were yours, were they?
Yeah, they were. Yeah.
I bought loads of them. I did a load of princesses, and I bought loads of them for that reason. And I bought a couple of extra, but I used my last one up on the 01 that I built last week. So if you've got any more lying around in a black hole somewhere.
Oh, we'll have a chat afterwards.
Yeah, brilliant, thank you. Because they were fabulous, those. There was loads of stuff in your range that I made. Right, sorry, I'm trying to get this. I'm dithering because I'm trying to get this bang on, because it's a bit of a death or glory soldering maneuver. This, I put a little bit of flux on the bottom of the windows, and I'm just going to put a couple of tacks on the bottom of the window frames there. Boom. And I'm using 145 degrees solder here. Right, that's just a couple of tacks just to hold everything together, and then we can get rid of the drill. Just check all is well. All looks okay. That. Check that the front lands nicely in the half-etched rebate that we'll create. And it does. So that's another bonus. Check, check, check. Check twice, solder once. So we'll do this corner now. Then you just kind of work your way around, really. Around the edge. I never do that thing where you try to solder the whole thing from the middle, pre-tinning it or anything, because you just end up with, blobs of solder all over the surface there that you just can't melt, and you can never plant the two pieces then right next to each other, right? So I just only ever solder around the edge. I don't know whether that's a bad procedure or what, but really it's just a bit of patience, a podcast of your favorite podcast on the speaker, and Just carefully go around the edge. I'm not going to go into the rebate. I think down that route would lie madness, although maybe I will just put a tack on halfway down the rebate and grind it out afterwards. There we go. Ow, burning my fingers. Don't let go though. There we go. Always do that. It's a bit of occupational hazard, isn't it? Burning your fingers while you're soldering. And you know, if you let go, the panels spring apart and disaster strikes. Right, let's just go around the window frames as well. And what I'm doing, look, is just clamping up the panel with a pair of tweezers while I'm soldering. Just tiny, tiny, tiny bits of solder on the end. Just it's a tiny pimple of solder on the end of my tip. Just enough to do that run of in the window frame there. Just enough. There's no point in putting loads on because somehow you have to get it all off afterwards. And it's much easier to do it this way. And I'm going to go in from the back of the two panels as well so that I don't end up getting solder in between the rivets on the outer face. That's always very difficult to get the solder off if you're doing that. And there we go. We just solder, and that's kind of what my job is really. Etching cusps, soldering, scraping paint off bearing surfaces. Very glamorous. Oh God, look, it started to rain again. I just wish sometimes, we went to Adelaide last Christmas and it made me wonder whether it would be nice to just live somewhere where there weren't so many grey days. I used to work with an American woman from Colorado, and she used to say that she loved the UK because it was so green and it had so many trees and no guns. And but she said she just wished that there were a few more days where it wasn't so bloody grey and overcast and dull. Anyway. Well, we're nearly out of time, guys. The other thing I should add as well is that I think a key, another thing that I've seen a lot is people bringing models that are really green. You know, the flux has just oxidized what you're looking at. The green is copper oxide. Is it copper 2 oxide? Or is it copper 3 oxide? I can never remember. It's been so long since I worked in a laboratory. So, you know, after maybe an hour or two of soldering, it's really always worth going downstairs to the kitchen and getting some bicarbonate of soda, sodium hydrogen carbonate. It's freely available in every supermarket. It's baking soda, not baking powder, because that's a mixture of bicarb and corn flour. And if like me you use phosphoric acid, which is a really weak acid, then a weak base like bicarbonate of soda will neutralize all of the leftover flux, especially the bits that have got stuck between these panels that we're soldering up now. And you'll see it fizz. It goes fizz, fizz, fizz. And when it stops fizzing, you can just wash all the residue away, and your panels then never tarnish. So that's always a good tip, I think. But there we go. We've soldered one side of the cab together, and this is the death or glory bit, isn't it? Where I offer this up to the foot plate to make sure that that radius there in the bottom of the cab matches that radius there. Because if it doesn't, then I'm going to have to move these rivets. And it doesn't quite. Bugger. It does on that side. Right, so that's out. It will be all right. Very good. Any questions? Because it's wrap-up time, I think, isn't it? So that's basically it. And the next job will be to solder those two together. And then what I would do to attach the cab side to the front is to get this is a piece of aluminium that's just really square. It's been milled so that all the faces here are at 90 degrees to each other. And what I always do is stick, which way around would I do it? I would stick the cab side with some insulation tape to the edge of that block, and then drop the cab front into the rebate and tape that to the block, and then I know that the two components there are at 90 degrees to each other, and you can just hit that join there with a little bit of solder, just tack it together somewhere, hopefully where no rivets have fallen, and then solder it from the inside and clean up. And of course you can see that the two panels are at 90 degrees to each other because they're stuck with some tape to my block. So that's kind of how I do it. And then it looks like the rebate. Oh, yeah, they fit over there. I see that there are some slots in the cab front there that go over the bit of frame in there. And it all fits quite nicely, actually. I'm quite pleased with that. There we go. Very good. Happy with that. Yeah, actually, it's not a million nails out. Let's just see if we can relieve this a little bit to make it fit better. The material needs to come. Oh, actually, the rivets, the set of rivets here that go all the way around the perimeter of this panel, they don't match the edge. They're not parallel with the edge of the panel here. There's a bigger gap. I'm wondering whether this is kind of a pre-designed in sacrificial edge, you know, that you can file away to make it match your curve here without losing the rivet. If so, then that's probably quite good design, isn't it? Anyway, that one fits much better. Still needs a little bit of adjustment, but we'll cross that bridge later. But sometimes if especially with riveted cab sides, if that curve doesn't match very well, then you end up losing the rivets, and then you end up having to re-drill and reform the rivets. You can't just have them not there, can you? It just looks rubbish. Let's see if we can make it fit in the last few seconds. Which do you think's the best layout that's on view then? Anybody been to all the layouts? Anybody got any favourites?
I rather like the Victoria Gauge Group shed.
That a good one, was it?
Well, it's not a scenic layout at all. It's just a club layout. It's like a test track, but it was quite impressive.
I'm gonna go and have a look myself now. Oh, that do you know what? That fits perfectly now, and the rivets haven't gone, and they still look parallel to the edge of the panel. Very pleased. Look at that. Ended on a good note there. Taking off tiny amounts each time just to be, yeah, be able to sleep tonight now. Very good.
Nick, have you ever done and maybe I've missed it since I'm relatively new to the guild, have you done an evening with, I know you did your workbench the other day, have you ever done one where you go through all your tools?
No, I don't really have many tools. I have been asked about this, but I don't have any. I don't have any machine tools. I don't have a lathe, and I don't have a milling machine. The current Mrs. Dunhill said that I couldn't bring a lathe and a milling machine into the house, and I have to say, I think she was probably right. I think it'd be a bit much, really, wouldn't it? Hang on, I'll tell you what, I'll give you a quick tour before we wrap up. There's the front bit. See, that's kind of the only machine tool I've got, and it's just a pillar drill. And it's, you know, I use it from time to time for making sure that holes are perpendicular to the thing. Hang on, let's go back to the webcam thing. Much easier if I take it down and waft it around the room, isn't it? There we go. Bear with. So the thing I did invest money in is buying a decent soldering iron. That's it there. Look, it's the Ursa Icon 1. And it did cost quite a lot of money. And that's the soldering iron there, look, the soldering station thing. But it was really worth the money because we soldering irons on all day, 5 days a week. And it's never let me down. It doesn't make soldering any better, but it certainly makes it a lot easier. I've got a really cheap mini craft mini drill there. Look, just as cheap as chips. It's real bottom of the range stuff, and it's got a really knackered German chuck in it that won't hold the drill now that's any smaller than 0.5 millimeter. So this is due for replacement soon. That thing over there, that bit there, is the power supply for it. And there you can see I've got an ancient H&M. I think everybody in the UK that's my age had an H&M Duet or a Clipper or something like that, didn't they, at some point in their life? Which I use just for doing analog testing of loco. I know it's not very good. I know that cordless motors really don't like sawtooth DC that old devices like that put out. They've got a very basic, so it's probably got a selenium rectifier in it, hasn't it, that puts out DC that's really sawtoothy. And I know that modern motors really don't like that, but they'll run for a few seconds. And then I've just got these hand tools, really. Look, I mean, there's a verniers, and there's the tin snips, and I've got a pile of tools here, pile of sort of Swiss files here, some of which really should be made into chisels or something because they're just completely worn out. I replace these all the time with again, Phil Atkinson at Hobby Holidays. I mean, I'm sure other suppliers are available, but he's quite close by and he has good terms. And I just replace them as I need them, you know, one by one. I don't really buy them in sets. I've got a bit of wood there, look. Can you see? There's a bit of wood there. Just there, look. Bit of wood there, and it's just drilled with increasing sizes of drills. I've got taps and dies here. I only really have a few taps and dies because most of the screws I use are BA screws. So I've got like 14, 12 and 10 BA taps and dies there. And I've got some grinders, and I've got a box of die grinders as well that I bought off eBay that were very cheap, but have done the job so far. My sister bought me a vice for Christmas. Hiding there, look. That's about it, really. I mean, it looks very disappointing, doesn't it? But that's kind of all I've got, really. Various solders, more solder over there, waiting to be used. I've got a box of drills that I was mentioning earlier. Coil of copper wire. Well, that's the copper wire that's not got lots of copper wire that you buy off eBay is designed for using in electrical winding, so it's got like a resin coating on it, but that hasn't. It's just pure copper. And that's kind of all I've got, really. I've got another riveting tool there that I never use. You can see hiding behind me just there. It's a Silbert's clock one that I bought donkeys years ago. It's one that you have to hit with a hammer, and then I realised that using a rivet punch that you have to hit with a hammer isn't such a good thing. But it's only there because I use the pointer thing I use it as a scriber. So that's really why it's there. It's just old describer. And that's it, really. The rest of the room's just full of junk, really. I've got a loco there in a case and an Avo just there. Look. There's my other interested looking about with old British bikes, and the Avo's good for that kind of electrics. Some books, and there's all my jobs that are waiting there on the shelf. Look. Kits that at some point I might get around to building for customers. That's it. Pillar drill. I've mentioned that, haven't I?
Yeah.
That's it. That's a lot. There's these drawers here. I've got all my materials in. The top one's rods. This one's tubes. That one's got screws and I don't know, broaches and reamers and things. And then there's a few farm tools in the bottom drawer. I always make my own farm tools. That's a thing that I made last week for finding the position of rivets, where the handrail knobs need to go on a boiler. You go along the side of the loco and the pointy bit there, you scribe a little line, see where you were drilling the hole, so that all the handrail knobs ended up in a line and level. That's it, really. I really don't have very many tools. Most of it's done by hand. There's a load of rods there that my dad used to work in a wire mill in Sheffield, and he liberated some stainless steel rods that I use for forming sheets around and things. Bits box there, look, with all the. I'm making a kit and there's some conveniently sized and shaped strips, then I chuck them in the bit box and use them later. Otherwise, there's over there on the shelving on that shelf there, that one. There, you can see there are loads of bits of what look like hardboard, sheets of hardboard, and in between them I've got all my different sizes of nickel, silver and brass, because a lot of the stuff I do is scratch built, so it's not really kit stuff like that. So that's it, really. I'm sorry it's not very impressive, really. I've got a scrap box over there, but I chuck all the waste panels in. Just there you can see it's got the boiler for the all one that I didn't use in the big square one. And that's it, really.
Thank you, Nick.
What's your camera, Nick?
This one.
The one you're using it.
It's just a remote webcam. It's an Oki thing. My wife bought it in COVID because she had to work from home. She has a big eggs job at the university. She had to work from home. They had to put teaching online during COVID in something like 2 weeks. And the webcam on our camera broke. So she bought this. And it's not particularly high res. It's really just designed for doing Zoom meetings and things, isn't it? I think we were on about this in my first presentation, weren't we? So I always have a problem with light in here. It's just an angle poise that I bought years ago from Habitat, for those that you remember Habitat. And
yes.
This is the gantry that I fastened me. It's purposed out of an old lamp. It's got bent here and forms a gantry to hold the camera over my workbench. But the problem is that I was telling James earlier, I downloaded some software onto my phone called DroidCam. And what DroidCam does is it connects your phone with your laptop, and it allows you to use your phone's camera as your webcam. And of course, phone cameras are much higher resolution, aren't they, than a crappy webcam like this. But the problem with apparently the problem isn't the resolution of the camera, it's Zoom itself. Because Zoom isn't very high resolution. It's just designed for doing what we're doing now, sort of chatting with each other, and not really for what I was doing earlier, where you're, trying to produce quite a high resolution image of you building something. It's kind of not possible on Zoom. You can see how grainy I am, can't you?
Oh, you're looking old, Nick.
Yeah, I thought that was age.
Oh, you're bad.
I don't care about that. I'm comfortable with me. Got no choice, really, have I?
No, none of us have. Nick.
No. No point in wasting any headspace moaning about that, is there? Really?
Thank you very much, Nick. Thank you, folks, for
Yes, thanks,
sticking
Nick.
with it.
Just a
And
complete tour.
we'll call it. I'll stop the recording, and we will call it a day. Thank you.
There's the model.
Bye-bye.
Thanks very much. Thank
See
you.
you all later. Bye now.